Here we've got the composition of functions, which means take the g function and substitute into it the f function. So wherever g had an x, we're going to be replacing it with this fraction 3 over x minus 1. Or if I do it in steps, the g function goes last, find out what the f function is, which is the fraction 3 divided by x minus 1, and then substitute that into the g function, which says the square root of 2 minus the fraction 3 over x minus 1. And now we need to find the domain of this function. Well, for domain there's two main rules. One is there is no division by 0. So if we had x equal 1, that would cause division by 0. So we automatically know x cannot equal a 1. The other main rule is that we're not going to be dealing with complex numbers right now. So whatever is inside of the radical needs to be something that is bigger than or equal to 0. So 2 minus 3 over x minus 1 needs to be bigger than or equal to 0. And now we can get a common denominator, which would be the x minus 1. So this needs to be multiplied on the denominator and the numerator by x minus 1. So then it's going to be 2x minus 2 and a negative 3 for the numerator, and the denominator is x minus 1. So we've got this rational function 2x minus 5 over x minus 1, and we need that to be bigger than or equal to 0. So it's saying a fraction is bigger than or equal to 0. Well, in that case, we could have, for example, a positive divided by a positive. That would be bigger than or equal to 0. Or it could be a negative divided by a negative. That would be bigger than or equal to 0. So we've essentially got two cases. One is the numerator and the denominator are both bigger than or equal to 0. So for case number 1, we've got the 2x minus 5 bigger than or equal to 0, and at the same time x minus 1 is bigger than or equal to 0. Solving for x over here, we would have x bigger than or equal to a positive 5. Divide both sides by 2, and x needs to be bigger than or equal to 2.5. As well as, according to this one, x needs to be bigger than or equal to a 1. So take a look at a number line. We've got a 1, and then somewhere over here is 2.5 or 5/2. So this is saying both statements need to be true, that it needs to be bigger than or equal to 1, as well as bigger than or equal to 5/2. So that would be where the two overlap, right here, from 5/2 to the right. And then the second situation, or the second possibility, is this where there's a negative divided by a negative. So we'd have the numerator less than or equal to 0, and at the same time x minus 1 is less than or equal to 0. Doing the same type of algebra, we've got 2x less than or equal to a 5, and x is less than or equal to 5/2. And x needs to be less than or equal to a 1. So again, with a number line, we would have a 1 about right here, 5/2 or 2.5 here. But in this case, it's going to the left. This one says go from the 5/2 halves to the left, and this one says go from 1 to the left. And so if both of those things need to be true, that's going to be this region from 1 to the left. So we're basically saying everything except what's in between these two. So on the left we have from negative infinity to 1. Usually with a less than or equal, I would put a square bracket. But from the beginning we said that x cannot actually equal 1, so I need to put a parenthesis. And then together with that, we use this interval, which it can equal 5 halves, so use square bracket, 5 halves, and then go to the right to positive infinity. And that should do it. But it would be a good idea to check by graphing. So graph this problem when we found it from the beginning, the composition function. Y equals the square root of 2 minus a 3, which is divided by, in parentheses, put x minus 1. And then close the fraction and close the square root. And then zoom standard, and we should be able to see the graph everywhere except between 1 and 2.5. And sure enough, here at x equal 1, the function becomes undefined. Just double check trace, try a 1, and it says the function is undefined. And at 5 halves, 5 halves, that's right here where the function starts again. And from there to the right, it is a part of the domain. So we finally have it. Great.